How are you? I think you have already watched the previous lecture of the network series in which we have discussed about the convolution and LTI system with their properties and various examples. Okay. Now we will discuss about the convolution property as we have already discussed the LTI system property. Okay. Now see convolution property. I will discuss property along with the example and the question so that you can get a clear concept, clear ideas. Okay. So the first property of convolution is nothing. So convolution property is that xt convolution with del of t minus t naught equals to x of t minus t naught. Okay, the first property for the convolutions. That means xt convolution with del of t minus t naught shifted version of impulse function is equals to functions, and that is shifted time given. Okay, t naughts. We have to put directly at t equals to t minus t naught. Okay. Now see the example. If x of t plus 4 into del of t minus 8, so that is we have to put this t minus 8 instead of t. So x of t minus 8 plus 4 is nothing but x of t minus 4. Okay, we'll get this one. Next example, if it is x of t convolution with del of 2t plus 3. Okay, so xt convolution with del of 2t, this 2t is scaling for this signal, so we want in the form of t. Okay, t plus 1, or so what we have to do, we can write it as but we know from the property that it is 1 by 2. Okay. We have already discussed in the impulse properties that if impulse is scaled by alpha into t, then if impulse signal at time domain is scaled by delta, that means we have already discussed this property del of alpha t equals to 1 by alpha into del of t. We have already mentioned. Okay. So we can write it as del of 2 t plus 3 by 2. Okay, we can write finally what we will get. We will get x of t convolution with 1 by 2 del of t plus 3 by 2, that is nothing but x into t plus 3 by 2 by 2. This is our answer. Okay, 1 by 2 x t plus 3 by 2. Okay, now let's see the third problem. We have used this property, scaling property, to find this one. So second problem, third problem. So we are given x of t is nothing, x of t is given by 2 tri, 2 triangular function is there, where t by 4, where t is 2 is the amplitude and it is the time period. Okay, t of 4 convolution with del of t minus 2. Okay, so we can write it as 2 into t ri into, so it is t minus 2. So t ri t by 4 So it is nothing but instead of t, put t minus 2 by 4. Okay, so you will put here. Okay, and question it is asked that find x of t at t equals to minus 1 and 1. So for this property we know that it has a time period of minus 4 to 4. Okay, this whole, sorry, it is nothing about this 4 to 4, and its time period it actually, okay, it's for 1 cycle this. Okay, 4, this is nothing but 2. This is convolution with shifted version of this one. Okay, del of t minus 2. So what will be the answer for this question? So we have to ask, it's asked that we have to find this one. Okay, well, we will see what will be the what will the result. So you know the result will be what? It is shifted by 2. So this is also shifted by 2. That means it is like this. Shifted by 2. And it is minus 2. Okay, minus 1 is somewhat here, and okay, now at t equals to minus 1, this is our nothing but 1. Now 4 becomes 2. You have to find the value of xt at t equals to minus 1. t equals to minus 1 क्या होगा हमारा? See, we'll put at t equals to minus 1, it is 2 tri minus 1 minus 2 by 4, that is nothing but 2 tri minus 3 by 4. Similarly, it is 2 tri 1 minus 2 by 4, that is nothing but 2 tri minus 1 by 4. Okay, now next question. See the next question, that you already know the product property and the shifting property as well as convolution. We will see here the result using all the properties of shifting convolutions. Like first one, exponential minus t into u of t del of t minus 1 delta of t minus 1 is what? It is actually multiplication, so it is nothing but exponential minus t minus 1 into u of, that is for 0 to 1 now. Okay, same into del of t minus 1. This is that is means exponential minus t minus 1 to del of t minus 1. Why? Because from shifting property of unit step function, what we know from the shifting property, or it is from product property. प्रोडक्ट प्रॉपर्टी क्या बोलता है कि अगर x ऑफ टी है और इसको मल्टीप्लाई करते हैं डेल ऑफ टी माइनस टी नॉट से, तो ये हो जाएगा हमारा रिप्लेस कर जाएगा यहाँ, तो एक्स ऑफ टी नॉट इंटू डेल ऑफ टी माइनस टी नॉट हो जाएगा. ओके, अच्छा, दूसरा है सेकंड क्वेश्चन, समेशन फ्रॉम माइनस इन्फिनिटी टू इन्फिनिटी एक्सपोनेंशियल माइनस टी इंटू यू ऑफ टी डेल ऑफ टी माइनस 1 है हमारा डी टी. तो क्या होगा? यूजिंग इंटीग्रेशन प्रॉपर्टी क्या बोलता है कि अगर इसको मल्टीप्लाई करेंगे तो जो टी माइनस 1 की जो वैल्यू है इसमें पुट करना पड़ेगा. मतलब ये डायरेक्ट वैल्यू हमारा कितना हो जाएगा, एक्सपोनेंशियल -1. इफ़ एक्सपोनेंशियल -t हो जाएगा इफ़ t इज़ द लिमिट बिटवीन -∞ to ∞. ये ओके. एंड थर्ड क्वेश्चन विल सी एक्सपोनेंशियल -t into u of t convolution with del of t -1. तो ये क्या होगा हमारा कन्वोल्यूशन किया तो कन्वोल्यूशन में दिस प्रॉपर्टी यूजिंग दिस प्रॉपर्टी इट इज़ व्हाट एक्सपोनेंशियल -t -1 okay to u of t -1. ठीक है. So this is the now we will see the next question. Now next question is that question number 12. Let's take that if x of t equals to u of t -3 minus u of t -5. Okay, it is given x of t equals to u of t -3 into minus u of t -5. Okay, and h of t is given, that is impulse function, as exponential -3t into u of t. It is given. Okay, it is given. So we have to perform convolutions. Actually question is asked about this one, and we have to find dx t by dt convolution with h of t. We have to find this one, and this is given. Okay, now by dx t by dt is what del of t -3 minus del of t -5. That means nothing but this one. It is given an exponential -3t, that means this one. It is given like this. Okay, now we have to differentiate. For differentiating, this should be changed to delta of -3. So at this it is actually at 3, at this it is actually -5, so -5 is there, no? Like this. This is nothing but differentiation. Okay, this differentiation, this means d of u of t by dt is nothing but impulse function. Is that okay? Now we can easily find the convolution. Now del of t -3 minus del of t -5 convolution with exponential -3t into u of t. So that is question, and it's really come out as convolutions में exponential -3 t -3 okay into u of t -3 minus exponential -3 t -5 into u of t minus 5. So this is basically our answer. Okay, so from second property is differentiable properties. Okay, differentiable property, it state that if x having m order function of t convolution with impulse function having order n function of t, then output will be y, order will be m plus n with function of t. Okay, where n is the order. We can say that d of x m t by dt, d of x m t to dt and convolution with delta of h m t convolution with is equals to dy by dt m plus n m plus just like this. This is nothing but convolution property. Okay, or we can say, or for understanding, if it is d square x dt by dt square plus convolution with cube del x of t by dt cube, then it will be dy by dt. It is 2 plus 3. It is 2 plus 3. Actually it is like this. Okay, very interesting. Okay, now third property is the scaling property. Scaling property, what it says that if function x of t is scaled by x of del of t and is convoluted with h of del of t, then the result will be 1 by scaling factor into y of 40. Okay, so scaling of one terms cannot be expressed in yaad rakhna. I was mentioned here that x of alpha t convolution with h of t is not possible, because scaling of one terms cannot be expressed in terms of other. In terms of other. Okay, so it's not possible. So this is the scaling property. First one is the convolution property of mainly the impulse. Second one is the differentiation. Third one is the scaling property. We have already discussed. We have already gone through it. Now we'll see the next property of the convolution is fourth property is reversal property. That is basically the folding property. It says that if x of minus t is this reverse of x function into function is convoluted with the reversal of the impulse function, then output will be also reversal. If both the input and system impulse response is reversal, then output will be also reverse. It is called reversal property. Okay, if we take example x of t convolutions with del of t minus t naught equals to what? X of t minus t naught. X of t minus t naught. Okay, so 1 minute. X of t multiplication of t minus t naught is what? It is nothing but fx of t minus t naught into del of t minus t naught. So what it is? Minus infinity to infinity x of t del of t minus t naught, where then it is x of t naught. It is shifting property. It is integration property. and this is for this. So if we take this signal, this is for sake of knowledge we have and to verify that this is property, is shifting property of a impulse function, that is called integration property. Okay, if the limits is between minus infinity to infinity, then only this is possible. Okay, directly write the answer. So now if we take this function x of t convolutions with del of t minus t naught equals to x of t minus t naught, if we replace t by minus t, so x of minus t convolutions with del of minus t naught is equals to x of minus t naught. Okay, so this is called reversal property. We will take solve an example. If u of t is convoluted with exponential minus t into u of t, and we don't know the output, what will be the output? So we can do one thing, that you know that in LT system Laplace transform, whatever x of t convolution in h of t is in Laplace, it is just multiply x of t multiply with h of t. Is for Laplace. Okay, if it is time domain continuous, and if we convert into this Laplace frequency s term, then we have to multiply that convoluted property. So for this, what we have to do, we have to just take Laplace transform, and for Laplace transform we know that for ut it is 1 by s, and for this one 1 by s plus 1. Okay, that is nothing but 1 by s minus 1 by s plus 1. So now we can take inverse Laplace transform to find out the output. We take here Laplace transform, and if we will get the final, do you know what we will get? We will get inverse of 1 by s is nothing but u of t minus exponential minus t into u of t. So we can write it as 1 minus exponential minus t into u of t. So this is, if we apply here, if we apply time reversal property, then what would be the effect? u of minus t convolutions with exponential t into u of minus t equals to 1 minus exponential t to u of minus t हो जाएगा, टाइम रिवर्सल प्रॉपर्टी से. Okay. अच्छा, एक चीज़ देखिए, this is one thing. If it is LTI system, we are giving here xt as an output, we are receiving here y of t. Okay, if we are giving del of t, then what we are receiving here h of t. Okay, and that is nothing but exponential minus t into u of t, and x minus t into u of t. And if we are given y of t, then if let us suppose that function is h of t is nothing but exponential minus t into u of t, then if it is go through this system, you will get y of t as 1 minus exponential minus t into ut. Okay, that means for this, what we will get this thing, and for this thing, for step signal we get 1 minus exponential minus t into ut, and for delta t we get exponential minus t into ut. If we with this convolutions. Okay. Why it is this one only? Because we have already discussed that this convolution with exponential minus t u of t is nothing but exponential minus t into u of t only. Or we consider del of t minus t naught convolution with exponential minus t into u of t is nothing but exponential minus t naught into u of t minus t naught. That is only okay. So for this property we have given impulse, we are getting exponential minus t into ut for impulse. If impulse response is exponential minus t into ut, by ut we are getting 1 minus exponential minus t into ut. Okay. And 1 minus exponential. Now see here the next if we are giving as x2t as a rectangular function t minus 0.5, if we are giving this one t minus 0.5, that means what? A rectangular function is shifted to 0.5. Hey guys, so see this one, it is x2t equals to rect t minus 0.5. That is means rectangular function is shifted by 0.5. And one thing you will be clear that a rectangular function is nothing but this one. That one is at minus 1 by 2 to 1 by 2. That is nothing but rect t function. And if it is shifted by 0.5, that means 0.5 means this here 1 by 1 by 2. Then it's become from 0 to 1. Okay now. Now see, we can write this in the terms of unit step function as u of t minus u of t minus 1. Can we write? Okay, so x of 2t is nothing, we can write it as this one. One thing, if input is for LTI system, causal system, if delay in input is reflected in the output, so if it is, then we can say that, of course, we can say that if x1 of t minus x1 of t minus 1, let us suppose it is as x of t, because it is nothing but okay. Then y2 will be nothing but y1 of t minus y1 of t minus 1. Okay, we can write here it is for y1 of t, what it is, ut, and ut impulse after conversion with relative, we can write 1 minus exponential minus t into u of t minus 1 minus exponential minus t minus 1 into u of t minus 1. Okay, insert it this one. Okay, that means if we send this signal if we send this signal to this one, we'll get this one. Here the output as this one, because ut into del of t, it is nothing but ut into st na, st, that will convolute it. Actually here it is what it is happening, it is ut into convoluted with h of t, and it is also u of t minus 1 convolution with h of t, so we will get this one. Now in the see the next question. We'll get the next question as let x3, it is there, it is given as r of t, that is the ramp signal. Okay, so can we write in the terms of t u of t, this one. Okay, what is t and what is ut? You know one thing, it is t is nothing but the slope is multiplied with this signal. Okay, so t ut, okay, t ut. Okay, and so we can write that r of t is nothing but, we can write here it is that for a y3 x3 in this, if we giving the x3 input in the Laplace LTI system, we are getting y3, and then output it is h of t is nothing but h of t is nothing but u of t, it is nothing but h of t. Okay, h of t. Then of course we will get y of theory, that is nothing but integration from minus infinity to infinity, and that is actually x1 of tau d tau. X1 is, and we know that x1 of tau is nothing but u of t, so we can write it as y of t equals to minus infinity to t y1 tau d tau, or we can also write it as for unit steps, that u of tau to 1 minus exponential minus tau to d tau, we can also write. I would just like to add some point that it is area property. Now area property, we have already discussed the differential property, shifting property, scaling property, the impulse property, convolutions property, and area property says that if x of t has an area of ex and h of t impulse response has an area of a of h, then the yt after convolutions have an area of ay, that is given by a of x into a of h. Okay, that means what? If we give this one x of t and having the area of ax, and we are getting yt having this h of t having the function system which has an area of ah, then yt is nothing but, it's an area of ay is nothing but a of x into a of h. So it's like example if y of t equals to integration of x of t into h of t minus t into d tau. Okay, so if we integrate this one, y of t dt, then x of tau into h of t minus tau to d tau into dt. So we can write it as x of tau into d tau integration h of t minus tau into dt. Okay, this one area. That means area is nothing for, this one is for ax, this is nothing but ah. Okay, and this is nothing but ay area. Okay, output area, input area, impulse, your system response area. Okay, we are indicating with respect to dt actually, both side. Now so we can write both side, integrate both side with respect to dt. Okay, good. Now see, solve the problem. That if del of question, this is question, so see this question of the area property. area property क्या, अगर del of जो impulse function है हमारा, impulse signal है, del स्केल किया गया है अल्फा से, convolution with again impulse function scale by alpha, then it is what, क्या होगा ये impulse function का क्या होगा. अब देखिए ये इसका मान लीजिए अगर ax एरिया है ना, और ये होता है एक्चुअली में 1/अल्फ़ा. ओके, तो इसका भी है ए वाई ए एच है, इसका भी 1/अल्फ़ा होता है. ठीक है, और मान लीजिए कि ये हमारा ए दिया हुआ है इंटू डेल ऑफ अल्फ़ा टी दिया हुआ, हमें फाइंड करना है ये कितना है, ए का वैल्यू. ठीक है, तो हम जानते हैं अल्फ़ा प्रॉपर्टी से कि एरिया ऑफ दिस वन इंटू एरिया ऑफ दिस वन इक्वल्स टू एरिया ऑफ y1, so 1/अल्फ़ा into 1/अल्फ़ा, nothing, 1/अल्फ़ा square. Okay, अल्फ़ा स्क्वायर हो जाएगा, मतलब ए इज़ नथिंग बट ए वाई इक्वल्स टू ए वाई अल्फ़ा. ओके, थोड़ा सा इसमें चेंज है. ओके, कोई बात नहीं, ये हमारा ही हो गया इतना. अच्छा, अगर कहीं पर क्वेश्चन में दिया हुआ है कि ए डेल्टा ऑफ अल्फ़ा टी कन्वोल्यूशन विथ डेल्टा ऑफ अल्फ़ा टी बराबर होगा ए बाई डेल ऑफ अल्फ़ा टी, जहाँ पे अगर इसका एरिया दे दिया गया हमें ए एक्स बराबर 1/अल्फ़ा बराबर इसका एरिया सेम ए एच. ठीक है ना, और ये दे दिया गया कि एरिया ऑफ वाई को नथिंग बट एरिया ऑफ वाई इज इक्वल्स टू ए बाई अल्फ़ा. तो हम कैसे निकालेंगे अल्फ़ा, अल्फ़ा जो हमारा ए क्या है, ए इज़ वाट, ए क्या है, तो हम जानते हैं कि एरिया ऑफ इनपुट इनटू एरिया ऑफ रिस्पॉन्स, सिस्टम रिस्पॉन्स इक्वल्स टू एरिया ऑफ दिस. सो 1/अल्फ़ा इंटू 1/अल्फ़ा इज नथिंग बट इक्वल्स टू ए बाई अल्फ़ा. सो अल्फ़ा कैंसिल आउट, so a equals to 1/अल्फ़ा. So okay, now see again one question. If sine of alpha t, if sine of alpha t convolution with sine of alpha t, it's give a sinc function alpha t. Okay, if its area is a of x is 1/अल्फ़ा, and for this its area is again same 1/अल्फ़ा, it is ah actually, ah 1/अल्फ़ा, then its area is, and its area is a by alpha. Then what is the value of this one? Of course 1/अल्फ़ा square equals to a by alpha, so alpha is a equals to 1/अल्फ़ा. So this is nothing but the okay. Similarly one more problem I am going to discuss. See, if exponential minus pi t square convolution with exponential minus pi t square again is equals to a exponential minus pi t square by 2. if it is area is 1, Okay, then find this area. Okay, for this area, ax equals to 1 equals to a, h equals to 1. Okay, and for this ay equals to what? Ay equals to a by pi by pi by 2. Why? इस तरह. So ay is nothing but, so 1 equals to, we can put here it as 1. So it is what it is. This will cancel out. So a root 2, a is nothing but 1 by root 2. Okay, ये होता क्या है कि अगर माइनस इन्फिनिटी से इन्फिनिटी है, a माइनस ए टी स्क्वायर होता है हमारा रूट पाई बाई ए. बहुत इंपॉर्टेंट ये भी है. और सिंक ऑफ एक्स होता है साइन पाई एक्स बाई पाई एक्स. ओके, ए वाई हमें दे दिया गया, ए वाई बराबर. Okay guys, we will see in the next lecture some problem of area property along with the various other property of convolution we will discuss along with the various problem also. Okay, bye.